Greetings, everyone, and I'd like to welcome you to our Eckerson Group Community Forum. I am Jed Somerton, VP of Consulting for Eckerson Group, and I'll be your host and moderator today. Speaking for all of us at Eckerson Group and Qlik, our sponsor today, we hope that you are staying safe and staying sane in our current health and business environment. We're glad you're able to join us. Today we're talking about 5 steps to success with data lakes, a major technical strategy that is powering some of the most valuable analytics today.
All right, thank you, Jed. Our topic today is 5 steps to data lake success. It is really a challenging thing. I think many of us have experienced the reality that it's probably easier to build a data lake than it is to get value from it. And that's some of what we want to address today. Getting value has to do with not putting data in, but getting data out. But it also has to do with making your data lake sustainable and a continuous flow of fresh data. So we'll talk about several aspects of what it takes to be successful with a data lake. And then we'll talk about the technologies that help you to step up to those challenges. So here's the reality. There are a lot of steps to get from source data to real value creation. We have to connect to data sources. We have to capture and ingest data. We have to store that data. We have to process it in various ways to refine it, integrate it, quality assure, and catalog and so on. And then we can deliver data to data consumers, and they have to use it in a way that delivers business impact. So at the source end of this continuum is very little value creation. At the business impact end is where we create maximum value. So the reality, I was quoted years ago before the age of data lakes in saying data warehouses, there is no value in a data warehouse. There is only cost in a data warehouse. The value doesn't happen until you take the data out and do something with it. That statement is absolutely true, and perhaps power an order of magnitude more with data lakes. Data lakes are costly to build, they're time consuming to build, they're costly to manage, they're labor intensive, and there is a huge amount of investment in creating a data lake, and the challenge is to get some return on that investment. So the message at the bottom here is the really important underlying concept for this entire discussion. And that is that storing a data lake is important, but it's only the beginning. The end game comes in taking that data out and doing something with it. So making data usable and accessible is the most critical step in value creation in a data lake. So let's look at the layers of value that we can get from a data lake. At the bottom level, we can get some value from data management. We can begin to address all types of data. The data warehouse was sort of constrained to relational data. We can get to all types of data. We can improve our ability to share data and to reuse data. And I want to underscore reuse. All data is reusable. All too frequently, that data is reusable but not reused. So we can create a data lake that is an opportunity to bridge that gap between reusable and reused. We can begin to break down the data silos, and data lakes have a much more flexible, adaptable architecture than the old legacy data warehouses. So we do start to get some benefit from data management, but it's limited benefit, it's limited value. If I take it up a level, we can begin to connect with the people who use data and the use cases that they use it for. So we can create value in BI and reporting without being entirely dependent on a data warehouse, and we can introduce new kinds of data, the big data, the unstructured data, the external data, the social media data. We can begin to introduce that to our BI and analytics world. We can improve and enhance business analysis by the ways that we can introduce new data. And as just one example, I'll give you customer relationship management and the discussion of 360-degree view of the customer that was popular in the early days of MDM. You can't get a 360-degree view of a customer if you only look at your internal data and their transactions with your company, because that's not the whole customer. They are much more than a customer of your company. So that external data contributes to that kind of business analysis. And the opportunities for data exploration to discover new things and to use data science, artificial intelligence, machine learning, automation, software bots, natural language processing, all of those things. We bring new opportunities for value that way. But still, improved data management and more users and more use cases, those are only opportunities for value. We don't get real value until we reach business impact. And the bottom level of that business impact is informed decisions. And we can also step up to the business monitoring kinds of things that are done with performance management and scorecards and dashboards. But the real value comes when we can start to drive digital transformation of the business and really start to integrate data into products and people and processes and services in such a way that it changes the nature of the business. And I think the pinnacle of business value is when we can use data to drive innovation. We're living in a complex world, rapid change, a lot of uncertainty, a need to respond to things as they happen, and it will be the innovators who thrive and those who fail to innovate who struggle and perhaps disappear. And especially as we approach the post-COVID era, and there is so much uncertainty about what's going to happen economically, socially, and so on, we really are going to need to become good at innovation to deliver the kinds of value and the kinds of business success that we need to deliver. So this is the kind of value a data lake really needs to deliver. But there are a lot of components to a data lake. And I won't step through all of these in any great depth, but it starts with lots of different kinds of data sources on the left, and then the need to connect with those data sources, capture the data, ingest it into and store it in the data lake. Okay. I want to focus a little bit on the capture piece because too many of us are still anchored in the idea of batch ETL to move data into the data lake. And when we want real-time data and we want it fast and we want it fresh, we have to think about step away from batch and think streaming. Now, most people look at data streaming when the data is naturally coming to them as a data stream. We can create our own data streams with change data capture. And I think that's an important thing for us to consider is when the demand is for fast data, we need to step away from batch mentality to be able to deliver fast data. And when we do that and we do it well, then we can process the data in the right ways to deliver it to the data consumers to support all of those use cases that I described and get to those business impacts of inform, monitor, transform, and innovate. Now notice also underneath all of this is a data catalog. Data catalog is the modern means of managing metadata, and we can't do any of this without metadata. We'll dive deeper into the data catalog later, but I want to point out that it is a very important understructure to this entire thing. So here's one of the places where we have to make a difference in taking steps toward data lake success. We need to accelerate the data using change data capture. I mentioned this earlier. If we can use change data capture to move data to the ingest process, and then if we can ingest it as a data stream, not inherently latent batch, we're going to get the data there faster. And the power, the efficiency, the impact of change data capture is underrelated and understated all too often. If we can capture real-time changes from database transaction logs instead of using extract, transform, load batch processing, we turn slow data into fast data. It's less invasive to your source systems. It moves the data faster. It gets it into the data lake quickly. Now, if we have use cases that don't require fast data, it is easy to slow down data that arrives fast. It's difficult to make slow data into fast data. It's relatively easy to slow down data that is arriving quickly and deliver it periodically to those use cases that only need periodic delivery. So accelerate your data with change data capture. The second important point is automate your data pipelines. Stop hand coding. Stop building everything from scratch. Stop building each data pipeline as if it is unique and special. There are design patterns in data pipelines, reusable, repeatable design patterns that we should be adopting and applying so that we deliver data pipelines faster, we deliver data pipelines with greater quality, and we deliver data pipelines with a higher degree of consistency so that when something changes, the impact analysis and the adaptation to change are easy. So we need to automate data refinement, we need to automate data transformation, and we need to do this in a way that is largely code-free, visual, craft your data pipelines through a visual interface, and only resort to code when you need to do something that's special and unique. So all of the repeatable patterns in data pipelines, those can be automated. They don't have to be handcrafted. And when we do this, we'll deliver data pipelines faster, we'll deliver higher quality data pipelines, and we will reuse many of the data transformations and the data flows and the manipulations that data goes through as it moves through a data pipeline. We'll reuse them. We don't have to rebuild them. We'll use things that have already been tested and proven and advance quality that way. Not only in building and delivering the data pipelines, but in executing them. We can automate execution, manage the workflow, manage the schedules, monitor the processing in real time, get to the business of orchestrating data pipelines. Now, this is really important because when you look at the studies on the failures to deploy and sustain analytic models, data science models, machine learning models, artificial intelligence models, the frequency of failure is mostly related to the inability to continuously deliver real data to them. Real, reliable, trustworthy, high-quality data. That's a data pipelines problem. That's a data engineering problem. I was speaking with Michelle Getz, a Forrester analyst, at a conference recently, where she showed me some research that says, although people talk about the shortage of data scientists, there are 12 times as many unfilled data engineer jobs as there are unfilled data science jobs. We can't hire enough data engineers. We can't train enough data engineers to meet the shortage. The solution to the data engineering logjam is automation. The third thing we need to do is we need to catalog and govern the data. A smart data catalog is essential. We have so much data now and we can't manage it without metadata, and we can't manage it through manual metadata collection because, one, there's too much of it. It's simply not, manual processes don't scale to meet the job. And the second is much of this big data comes to us from external sources without adequate metadata. It takes data exploration. It takes a smart data catalog using algorithms to crawl this data and discover the metadata and capture it. So we need this data catalog to give us the content metadata that tells us what we have in inventory. If we don't know what we have, if we can't find it, we can't use it. If we don't use it, we fail to deliver value. We need sensitivity metadata so that we know what data is privacy sensitive, what data is HIPAA sensitive, what data is subject to GDPR regulations, and so on. We need to know which data needs to be governed and protected. And to do that, we need crawlers that can discover these things and tag the sensitive data that needs data protection. And we need semantic metadata. We need intelligent algorithms that can do semantic inference and discover data that is about customers, data that is about suppliers, data that is about products, and so on, so that it can be tagged, so that it can be found through searching. If we don't know what data we have, if we can't find the data, we're not using the data. If we can't find it and use it, we're not delivering value. And we need to curate a data marketplace. People who are consuming data today, the self-service data consumers in particular, but really all of the data consumers, need the ability to find the data and get the data in an easy way, to have an Amazon shopper-like experience in terms of seeking data. A data marketplace should give you all of the capabilities to search, to understand, to evaluate, to see the ratings of others, to see related kinds of data sets. All of those kinds of capabilities that you have when you shop on Amazon for a product, you should be able to have with a data lake and a data marketplace when you're seeking data. So data lakes create value when the data is accessible. The catalog bridges that gap between accessible and accessed. So the catalog is the foundation of a data marketplace, and then the data marketplace provides all of that shopper-like experience. Search, understand, evaluate, and so on, that will invert the traditional analysis cycle that says I spend 80% of my time finding and understanding data and only 20% analyzing. We can turn that upside down so that it's 20% finding and understanding data and 80% analyzing, which doesn't mean longer analysis spans. It means greater capacity to do more analysis. So with that, I will hand off to Ritu, and we will see how some of the technology can support these critical things that are so important.
Thank you, Dave. That was great. So good morning, good afternoon, everyone. Thank you for joining us today. Before I start talking about data lake creation and how Qlik enables organizations build performant data lakes that Dave has been talking about, I just wanted to give a quick introduction of who Qlik is, especially for those of you who are not very familiar with us. We're a data and analytics company. We have 50,000 plus customers worldwide and presence in over 100 countries. We're a leader in both data analytics and data integration space. In fact, some of you probably know us as a data visualization vendor or have used our product QlikView in past. We have a long history in data analytics space. Gartner has been ranking us as a leader in their BI and Analytics Magic Quadrant now 10 years in a row. We're also seeing a huge momentum in data integration space. In fact, Gartner just very recently named us the fastest growing vendor in data integration market with 70% plus year-over-year growth. We work with about 1,700 partners worldwide, SIs, resellers, as well as technology partners like Microsoft, AWS, Snowflake, Google, and more. And in terms of what we do, in the simplest statement I can think of is that we help organizations turn data into business value by providing solutions for end-to-end value chain from data to analytics to insights. Our solutions fall in three major categories: data integration, to turn that raw data that you're collecting into analytics ready state so that your data science teams can work on that. Data analytics, to take that analytics ready data and then convert it into actionable insights. And then data literacy as a service to provide education and consulting support to organizations so that they can actually take advantage of those insights that they are generating to drive business value. So let's talk about Qlik solution for data lake creation and the key building blocks. But before I do that, I just wanted to give you a quick overview of the overall approach for data lake creation that Qlik has. We adopted agile approach towards data lake creation. And by that, I mean, what we have done is, in terms of data lake creation, we've automated the entire data lake pipeline process all the way from real-time ingestion of data to creation and provisioning of analytics-ready data. The solution is based on our experience of working with 2,500 plus companies all over the world, and it incorporates some of the best practices that Dave was talking about in building a data lake. Our focus is completely on not only simplifying the entire process of creating a data lake, but also accelerating it so that you can maximize value faster from your data lake initiative. So let's look at the overall solution. If you look from left to right, there are 3 core components and capabilities that make our data lake solution. On the left-hand side, if you start from left, we provide market-leading change data capture capability so that you can access and ingest data from virtually any enterprise source, be it a data warehouse or a database or your legacy mainframe systems or enterprise applications. We enable all of that so that you can load your data lake storage very, very quickly, whether that data lake storage is on-prem or in the cloud. Once the data has been landed in the landing zone of your data lake storage, our data pipeline automation capability picks up that raw change data and it standardizes and formats that data. It merges those raw change deltas in order to create analytics-ready data. It also enables subsetting of that analytics-ready data so that it can create the views that your data consumers need in order to feed your AI models or your other modeling needs. And then just like Dave talked about catalog, while all this is happening, the integrated cataloging capability that Qlik provides is generating rich metadata on all your data in data lake so that your viewers and your users can actually very quickly search and understand for data, self-provision that data, and then consume that data in an analytic tool of choice. So even though Qlik offers Qlik Sense, a very strong, very powerful analytic solution, the solution for data lake creation from Qlik is actually platform agnostic. If you've already invested in an analytic solution, in past you can use any of those analytic solutions to do the analysis, to consume this data. So let's talk about each of these components a little bit more in detail. And then I have Brian here, who's gonna be doing a demo at the end and showing how these pieces work seamlessly in order to help you create that data lake. So Qlik Replicate is the very first component in the Qlik solution for data lake creation. And it helps you access and ingest that data from your enterprise sources. The solution provides universal connectivity, so you don't only have a wide set of sources that you can ingest data from, but you also have connectivity with a very broad set of target endpoints that you can land data into. The solution supports technology stacks of pretty much all the major cloud providers, so that you can not only plan your data architectural needs for today, but also for future, because we understand that architectures are changing. We also know that companies are merging, acquiring, etc., and a lot of them are living in hybrid multi-cloud environments. So we make sure that as your needs evolve, we support those needs. Qlik Replicate also supports both bulk and incremental load. So, Dave was talking about this need to turn your slow data into fast data. Not only the solution takes data and loads it in the batch mode, but as soon as that's done, it's actually capturing changes, real-time changes as that they're happening, so that you have up-to-date data at any point of time in your data lake. And our change data capture capability is agentless and log-based. And what that means is that when those real-time data changes are being captured, it is not impacting the performance of your transaction system. It also supports change propagation, so any changes to your data structures that are happening in the source side, or any fields being added, deleted, columns being added, deleted, all of those changes get propagated into your target system so that your source and target systems always remain in sync. And then the whole idea about automation, we provide an interactive UI with the solution. So your data engineers that Dave was talking about, and he was talking about how they are one of the most scarce resource most organizations have, they can set up those pipelines in a point-and-click manner without writing any code. So the UI with the solution that comes, it's interactive. Point-and-click UI allows you to set up your data pipeline and monitor and manage those pipelines without writing any code. So once Replicate hydrates your data lake, Qlik Compose for data lakes, which is the second component for our solution. It basically helps you automate the entire process of processing and refining raw change data to convert it into analytics-ready state. Qlik Compose for data lake actually has a native integration built with Replicate. So any data that is landed by Replicate into your data lake, it basically picks up that data automatically. It standardizes, formats that data, and merges those change files in order to create operational up-to-date view of the data. Qlik Compose for data lakes actually can also, for Hive projects, pick up data that has landed by other processors like Apache Scoop. And the solution, again, going with the whole concept of automation and ease of use, comes with an interactive UI. So your data engineers and data consumers, they can very, very quickly transform data. They can, do standard calculations, or they can transform attributes in a simple point-and-click manner. They can even, for most frequently used calculations, they can even create and save workflows so that those don't have to be written again and again, or those don't have to be created again and again. And it allows for reuse, increased productivity, lower risk. The solution auto-generates Spark ELT, so your data engineers don't have to write ETL scripts. That ETL is generated on its own, and then it's pushed down into the engine for processing. And once data is refined, the solution even enables you to subset that data into different views depending on what the requirement is from the data consuming side. It can create current or historical or a snapshot in time views of data so that you can use it for your AI and machine learning models. And the entire workflow, all the way from transformation to subsetting data, can be created once and then reused multiple times with the idea to automate, accelerate, and reduce the risk. And then the last component of the Qlik solution for data lakes is our cataloging capability. And to Dave's point, he was talking about how important cataloging capability is, because you can hydrate your data lake, you can convert that data into analytics ready mode, but if you can't trust your data, if you don't have confidence in your data, then you can't trust the results that come out of that data. And that's where Qlik Catalog comes into play. It basically helps you manage and govern data. It also makes data accessible through a data marketplace. So let's talk about this. Qlik Catalog is interesting because it basically not only auto-generates very rich metadata on all the data which is in the data lake, but across all your enterprise sources. So your users have visibility to all data that you have within the enterprise, and they can basically access that data. It also allows your users to add metadata so that they can enrich the metadata further with context, with what's going on around at this point. The solution persists history of all the changes. So any changes to data structures, any changes to data, all that history is maintained for end-to-end lineage so that users have trust in data. They can see how the data was transformed and changed over time. And then it comes with a number of security and governance capabilities so that you can encrypt data You can mask your more sensitive PII data to meet your GDPR, CCPA type of requirements. And you can also administer enterprise-wide access control so that people only with right security clearances have access to that data. And then finally, you need to make this data accessible. So Qlik Catalog also provides a data marketplace capability, where in a very online shopping experience type of setup, just like you get on Amazon or other online sites, you can not only search and evaluate data, but you can select and self-provision that data to consume it and action on it. So you can see how the whole solution has been designed with the idea of not only simplifying the creation of data lake, but also accelerating the creation of data lake so that you can maximize value, and it meets those parameters that Dave was talking about of not only storing data in data lake, but also making it usable and accessible. So with that, I'm going to pass it on to Brian so that he can demo the product to you.
Thanks, everyone. Today, I'm going to show how simple it is to accelerate the development of your cloud-based data lakes, automatically generating the code needed to stitch and transform the data into the data lake. And with that data lake being hydrated from enterprise sources, we will then catalog and govern the data, making it highly accessible for self-service users in a marketplace who can generate insights immediately, all within the automated Qlik data integration platform. I'm going to start the demonstration here with Qlik Enterprise Manager, which is the place where you can centrally manage and administer an analytical data pipeline. All pipelines, once built, need to be managed, need to keep the data flowing. And here we start with a server view where I can see servers for a couple of the key components, Qlik Replicate and Qlik Compose, showing things such as the resource utilization, the number of tasks that are starting, stopped, and so forth. This has the ability to set enterprise security on your whole environment. We have the ability to put audit controls in, so you can have audit trails of all of this. We have the ability to drill into the server's level itself and be able to, the task level itself, and be able to see individual tasks and control them like you were on those servers. So a single pane of glass to control your enterprise. You can also analyze what's going on, being able to trend the performance, fix bottlenecks, plan capacity, because we're going to be collecting information like you see here and really storing it in a analytics repository about how your environment's performing to keep things moving forward. We also have the ability to track metadata and lineage, and I'm going to come back to the lineage piece when we get to the catalog, because you'll be able to see all of the pieces together. So centralized control center to start with. Now I'm going to move into Qlik Replicate, which is where we bring the data into the data lake. First into a landing zone, being able to load either bulk or streaming using highly efficient change data capture. And here you see our Qlik Replicate GUI. I could control it from Enterprise Manager. I'm going to show you a little more detail in here. The first thing is you need to set up connections to where you want your data to come from and where you want it to go to. And I'm just going to show you here, I have a source set up to bring data out of a relational enterprise source, MySQL, and I have a target set up here for my data lake, which is in the Azure cloud using HD Insight. I can see I have an SSL cert path. I have all of my Azure Active Directory connection information and Hive access so that I can get in and look at that data. Now, being able to get that data moving doesn't require any code. All you simply do is follow the GUI. And you ask it, name the task. You ask Replicate, what do I want this task to do? Do I want to move data in one direction, bidirectionally, or multicast the data? And you give it options. The full load option will create the tables if needed and do that initial bulk synchronization. Apply changes will apply changes directly to the target tables, kind of what you think of when you think of change data capture. And store changes will actually create an audit table for each table, which is very valuable in the Hadoop data lake world because we can get the changes and more easily stitch them in. The GUI controls everything. You just simply pick the source and the target. I'll pick the two sources that I showed you, the OLTP source and the HDI landing. And then you just pick the tables you want. You just open up a GUI here. You just pick the schema that you want. You pick the tables, and you can add global transformations if you want to. You can go into the tables and add table level transformations if you need to. You can set additional parameters in the task settings. All of this is done without needing to write any code and create a task and create an environment for moving the data. I'm going to go ahead and save that, but I'm not going to run it. I have a task already running here with that same information. I can see the same tables, the MySQL source, the Hadoop landing zone. And I'm going to go to the monitor tab where I've already done the full load ahead of time just to save a little time in the demonstration. I can see all of those tables are there, and I'm in change processing mode where Replicate is streaming that data, checking the logs every few seconds for information. In fact, I'm going to go to my source system and go ahead and just create some traffic so we can actually see the data start to move. I just have some SQL statements here on my customers table, and I've gone ahead and just done some inserts and deletes on the data. And I'm going to go back to here, and I could see those changes already coming in and recorded. So those have already been picked up by Replicate, and they'll be streamed to the landing zone. We actually do that on a matter of minutes. So, you know, a Hadoop data lake is close to real time, but it's not a true real time structure. And we do that very specifically to manage that platform. And that's something you can control in the settings, by the way. You can go into the change processing settings, and you can see here you could determine how frequently you want to write change partitions into the Hadoop environment. So with that, we already have the data flowing and we already have updates going. Now I'm going to move into Qlik Compose for data lakes. And this is where we really automate the data lake pipeline itself. First of all, these three tabs really define everything your data lake administrator will be doing to create and manage their data lake. First of all, you set up connections, and we have connections to our storage zone. We create a single stored copy of the data in Parquet format that we can manipulate and provision out different ways for analytical users. And I'll show you more about that in just a second. So here we can see just all the typical data lake parameters, storage accounts, file systems. And also we have all of the different, we have just one source currently, but you will have many sources in the data lake. So you'll see in this landing lots of additional sources added in here. We named the replicate task this is coming from. We have the option to do things such as automatic schema evolution, where if you add a column, change a column name, and so forth in your source system, and you want that to be automatically reflected in the data lake, we do that for you. So with the connections set up, your next task is to determine what you want to manage in the data lake. And we do that by discovering the data. We'll pick a set of objects that we're looking at in Replicate and be able to just select those, add those in. And I've already done that. So I'm going to go ahead and open them up and see what you see. So I have here, different tables such as the customers table. I could see, I have a logical view with a key, the attribute name, the data type, and this construct of a domain. When we see a type of data, to maintain consistency, we give it a domain. So everywhere I'm using city, I can be confident that it's all the different tables that might have it. We're going to keep a standardized notation for that. So they'll all be varchar 15 or whatever we need it to be. Not just a logical view, but a physical view of the underlying Hive tables we're going to create. And in doing that, we are going to add a few different things to that. The batch that we most recently modified this, a from date, a logical delete flag, and the physical attributes of that. So all of that is available. Now that we have a model, so to speak, of what's in our data lake, we're going to go into the data storage tasks. And here's here's where you're going to see something that looks kind of like your typical data integration tool. We're going to have, for this source, a storage mapping for each of these tables. And if I go and open one up, we're seeing typical source to column target mapping. Now, while you don't typically do a lot of transformation in the data lake, in case you need to, such as, maybe I have a product name and I need a product ID, I could go ahead and do a lookup to another table. So I could do lookup style transformations. And maybe if I needed to make a calculation of what the discount was, I can create expressions, and those will become part of the automatically generated solution that we offer. Now, as soon as I generate that, I'll have all of the task commands built. And in this case, we're going to be creating scalar Spark SQL. So I could open up one of the tables. Maybe I'll stick with the customers table. And here, we have the load statement of the of scalar Spark code that is automatically generated, maintained by the solution. Click of a button, I make changes, it will add those changes to that. So that's just to get data stored in a centralized format. But when we provision the data, what we do is we can take that data and format it different ways for specific use cases, such as a historical data store or an operational data store. So here I have a historical data store and an operational data store. I'm going to open up and edit the sales historical data store. I can see I just pick what I want this provisioning to be. I choose the tables I want. In this case, I have categories, customers, order details, products, and so forth. And I specify, again, that Hadoop level connection information that's necessary. Now, one thing that's different is we don't have to store this in Parquet format. We have other binary formats available, namely Avro and ORC. And I can make these provisioned data sets having any of those. And I have a historical data store, which is actually going to generate Hive SQL and use the ACID merge capabilities resident in most Hadoop data lake platforms. So with that's all I need to do to create a data lake, but I need to keep it running. So here I can see I have a workflow that's already built. And I've just created this workflow. If I wanted to open it, I see I just drag and drop objects to go ahead and build a workflow where I'm going to process changes through my storage layer, and then I'm going to run the historical data store and the operational data store, wait till both of them finish, bring it together, and end the process. And I can do other things too. I can have command tasks that bring external components into the workflow, and anything I need to do. Of course, I can keep this flowing by using scheduling and notifications. For now, I'm just going to go ahead and kick this off and run the data set. So not only have I built a data lake, I'm flowing the data through the data lake. So with that, while that processes, I'm going to move and talk a little bit more about cataloging and bringing the data set into a marketplace type of paradigm. So I'm going to log into Qlik Catalog, our cataloging tool, and here I can see I have a catalog of all sorts of sources, not just my data lake, but warehouses, really anything else in my environment. Now I'm going to focus on that data lake. So I'm going to filter and look for a particular source. I'm going to look for the sales historical data store. I'm going to apply that. And here I see all of the objects from that historical data store. And at a high level view, it tells me kind of some key statistics about those entities. What's the operational efficacy of this data set? Is it something that is loaded, is successfully loaded frequently? Does it have some issues being loaded? What's the quality of this? We have 40+ built-in rules, and you can create custom checks as you need to determine the quality assessment of this data set. And we can control PII data, tag PII data, and all that kind of stuff, as well as the popularity of how frequently this is used. So I'm going to pick one of these entities and drill into it and see in a little more detail. And here we see the quality scores on the side, the description. I could put in a little more detail there. We have a profiling of all of the entities in here, data types, range of values. We have all of those properties that we've checked, as well as how this relates to other data. So very important there. The other thing that we have is lineage. So if I click on the lineage diagram, and I'm going to take this and actually up it to all the levels. So I could see going back all the way to the source, bringing it through replicate into the landing, being able to put it into our storage zone, being able to put it into the historical data store, and then I go ahead and build out some Qlik Sense apps from this. So that's a very powerful thing. I have the ability to, I got that data in the first place by being able to set up a source to this. I just set up a source to connect to my data lake, and in it came. So going back, one of the key things to be able to do is go ahead and tag some of this data. So if I wanted to pick maybe my customers, my orders, my products, and maybe the order details, and go ahead and add these 4 things to a cart, I have the ability to take actions on this newly formed data set. And one of the things I could do is go ahead and publish this directly into self-service, directly into my BI tool. Now, it's going to take a minute to go ahead and process that. So I'm going to, it logged me out during the demo, so I'm going to log back in and kind of show you the data set that I had. It's one of the things that happens in a live demo. But I'm going to go back in. I've prepared kind of what this data set would look like. And here I can see the shipping costs by the different countries. If I wanted to make selections on this, I could go in and maybe look for country. I could go ahead and tell it to select all of them. Go back out here and be able to see, most of my shipping costs are in the United States, but I had a nice map that shows me everywhere I'm shipping to in the world and the different products that I'm shipping. So those kind of analytics built almost immediately out of the data sets that I've prepared, cataloged, and made available. So that concludes the demonstration part of this. So I am going to quickly jump back to a couple of slides so that Dave can finish. Over to you, Dave.
Okay, thank you, Brian. Great demo. Let me just quickly put the wraps on this, connect us back to that title, 5 Steps to Data Lake Success. We've talked about 4 of these already. One of the keys to success is moving data at speed. Accelerate your data, turn slow data into fast data, and use change data capture to do that. The second step is automate. You need to be able to produce a large number of data pipelines efficiently. You have to be able to reliably deliver timely data to those who need it. And automation is the key to that. As I said, and as Ritu underscored, we cannot produce enough data engineers to do this the old way. The third step is to really truly embrace cataloging and see cataloging as one of the important governance tools. As we introduce more data, as we move toward greater self-service, as we see increasing numbers and kinds of regulations around data, governance and access controls are going to be critical, and the catalog is going to become a critical tool in data governance. The fourth step is curate. I didn't use that term earlier, but curation is an important aspect of creating a data marketplace. If you put data into your data marketplace without the supporting metadata, the descriptions, the information that helps people to understand it, to evaluate it, to decide which data to use, to know who are the subject matter experts, who are the data stewards, and so on. If you don't do the curation activities, it's really, truly going to struggle. So we talked about those 4: accelerate, automate, catalog, and curate. And the 5th step is to future-proof. One of the things that I know is that technology is constantly shifting, and when new technologies emerge, it often creates a challenge for us to keep the pace. If I reflect back on my days when I was an IT manager and an IT director, one of my greatest challenges was the ever widening gap between the leading edge technology and the trailing edge technology. It seemed that we were always pushing the leading edge and we never had time to go back and pick up the trailing edge and pull it forward. And the gap got wider and wider and wider, and my budget and my staff didn't grow. So the ability to adapt to the future without that kind of impact is very, very important. So you want a solution that's platform independent, that will adapt, that will help you deal with changing technologies and changing data sources. So those are the 5 steps to success. There is a corresponding white paper that supports this webinar. It's called A Guide to Maximum Data Lake Value. That was published just last month. You can simply go to Qlik.com to their resources page, and you'll find this Guide to Maximum Data Lake Value and can download it and read about everything we've talked about today, plus more in greater detail. So thank you very much. With that, I'll turn back to Jed and let's talk about questions and answers.
Thank you, Dave, and Ritu, and Brian. I got a lot out of that, and I hope everyone found it a good use of your time. We have a few minutes for questions. We had a couple come in through the chat window, and I'm going to direct one of them to Ritu and perhaps another one to Dave. So the first question, is all data in the data lake available in the data marketplace? And is the marketplace limited to just data that's in the lake?
It's not just the data from our data lake. It can be from external sources. It's basically anything you want to catalog. What I showed you in the cataloging, you can create connections to all of your enterprise data assets and have them all together.
Perfect, thank you. And Dave, you had a really nice point at the end there about you're never picking up the tail, you're always moving the head. Is it really possible to future-proof and pick up that tail with the speed of technology and change today? And how do you manage the cost of doing that in the big picture here, to be able to adopt a technology like the data lake and Qlik and still not leave your old stuff behind?
It maybe is not possible to entirely future-proof to guarantee no impact from future changes, but it is certainly practical and makes good sense to anticipate those changes, to be ready for them, and to do the things you can do architecturally and technologically to minimize the impact of change. So if you're selecting platforms that are not tightly coupled with other technologies, if you're selecting platforms and products that integrate and work well together with other technologies and have other vendor partners, if you're constantly aware of the vendor roadmap for the kinds of products you're selecting and look at how they're growing into the future, you can take all these mitigating steps that will minimize that huge impact and look toward building a data management environment, a data lake world that is continuously able to evolve as technologies change. So no, I'd say you can't 100% future-proof, but you can do a lot more than just be a victim of change.
Well said. Well, thank you, folks. That's coming up to the top of the hour. Greatly appreciate you joining us. If you found this to be a good use of your time and you're on social media, we would appreciate a mention. And if you have any feedback for us, how we might improve, please send it directly to the man, Wayne@Eckerson.com. Thank you, and we look forward to having you in our next webinar. Stay safe and keep moving forward. Goodbye.